Hey everybody, Ryan again, and I wanted to make a quick follow-up, an errata slash addendum follow-up to Dark Mode Episode 2. So if you have not just previously watched Dark Mode Episode 2, then please don't watch this video yet. Go back and watch Dark Mode Episode 2 first, because this little short video will not make any sense without that context. In Dark Mode Episode 2, if you'll recall, in the source code for the DLL that I was writing, and I remember we went and we looked at this, where the user's plaintext password was in the RCX register. Well, of course, this is not the register itself at this point. We're actually talking about the context record that's part of the EX data structure, right? So, and then I'd forgotten. At first, I was second guessing myself, saying, wait, maybe it's right to left, not left to right. So maybe the plaintext password is actually in RDX and not RCX. So that was issue number one. I actually should have never second guessed myself. It is RCX, okay? It's definitely RCX. And then the second thing is I forgot why I had to do +8. And I just remember when I was putting the material together for this episode, I was debugging this originally with a time travel debugging trace, and I could see the plaintext password that I wanted was in memory. Like, I could see it in memory. It was just 8 bytes to the right, and I didn't know why exactly. I was just, at that time I was like, whatever, +8, that's my password. And I'll show you, now that I've had time to think about it, obviously know why. So I can prove it to you. I have a time travel debugging trace open here. This is a time travel debugging trace of the LSAS process of the Windows 11 workstation after I had already injected my DLL, replaced the unhandled exception filter of LSAS, and patched the system function 7 function. So as you can see in this LSAS trace, like this right here, where the exception is thrown, this is my password change process, right? That, because remember, we patched system function 7 with the UD2 instruction to purposely raise an illegal instruction, unhandled exception. So let's go ahead and make sure I don't have any breakpoints set. Breakpoint on crypt_sp system function 7, and go. And there we are. We get there immediately, and you'll see that I'm currently sitting on a UD2 instruction right now, which is the one we wrote, right? So if I unassemble that, you can see these are the bytes that we wrote in here. Remember, I do the UD2 and then the 3 NOPs right after it. So I know that the next instruction I execute is going to raise an instruction. Anyway, I can also tell you right now that here are the registers, right? And then RCX being the register. Recall, and this is one of the things that I forgot, was that this is not just a pointer to a string in here. This is a pointer to a Unicode string data structure. Unicode string, strong Unicode string, right? So what we have here is we have a length, which is a U short, that's 2 bytes. We have a maximum length, which is a U short, that's 2 bytes. And then notice that there are 4 bytes right in here that we can't account for. And then at 8 bytes, you have the pointer to the actual string. The 4 bytes, of course, being alignment space. It's alignment space that it's padding space that's added by the compiler to ensure proper alignment for optimal performance. So that's where those 4 bytes went. And for example, if I do this address, which is an RCX right here, because we're at the very beginning of system function 7, hold on, DT Unicode string with that address, you can see, and I've highlighted that address for you, obviously you can see it popping up, but yeah, there it is. This is our plain text password, foo123bang, length, maximum length. Okay, so now what we need to do is, as you can see, I step and I immediately go into KI user exception dispatch, doing all this exception handling stuff. And I could just sit here and go through this exception handling stuff for a long time. But I could also set a breakpoint on something that I know that we will be hitting shortly, which is breakpoint kernel base bang output debug string A. And I know that because we use it right in here. We do this comparison right here, and to make sure that it's an illegal instruction exception, and then the very next thing we do is print that out with output debug string. So when we hit that, I'll know that we're in the right place. I have to do it that way because I didn't compile this DLL with any sort of debug symbols, right? So I don't have any symbols at all for hacks.dll right now. I could go back and compile it with debug symbols if I wanted to, but I figured we already got this far, so we don't need to. So I hit G for go, and the next thing we do is we hit output debug string. You can look at the call stack. You can see that, I've got system function 7, which then goes through all this exception handler stuff. Right, which sort of like proves to you that this has some sort of performance impact, no matter what the numbers say. You can't execute all of this stuff for free. But I digress. We get to hacks bang DLL main, which of course I have the DLL main symbol or address because it's an export, right? It's a DLL. Naturally, you're going to be exporting DLL main, but that's the only symbol I have. And then output debug string. So at this point, you can see the registers have different stuff in them. If I back up a little bit, I will eventually get to this step right here, and this step really stands out to me because we're comparing a constant. We're comparing the value of whatever is in RAX with some constant. Right, and I recognize this constant because we worked with it throughout the entire video. Right, that's the exception code for illegal instruction. Right, and we're making a comparison to say, is this equal to that? And if you look at our code, there's it's very clear that that's what this line here is doing. So we know we're at the very beginning of this function, right? So stepping back just a little bit, and what I'm going to do now is, so now I can assume that my registers should be properly set up, right? So what is RCX going to be at this point? RCX, I assume that is our exception pointers data structure, right? So I assume that whatever this is in RCX corresponds to this right here, our exception pointers data structure, right? Notice it's not the same address as RCX, it's something different. So if I take that and if I disassemble that, or if I DT that as that address as exception pointers, and click on context record, yep, this is it. And see, this was our original RCX. So remember, it's not the literal RCX that's in the processor register right now at this exact moment. That would be the EX data structure. This is the copy of what the value of RCX was at the exact moment that the exception was thrown, which is, of course, the same thing, our string, which we already did, right? BT Unicode string and that. And so if you do that address plus 8, it will take you right to foo123bang. So that was the reason for me doing a plus 8 over here, which I've already, there we go, a plus 8 over here. Right. All right, so that's fully understood now. I just wanted to make that slight correction because I didn't explain it that well in the video originally. And one other thing that I wanted to mention, I figured it would be a frequently asked question is, could I just turn on run as PPL and prevent all this? And the answer is yes. Run as PPL will definitely stop this run as PPL. Configure added LSA protection. Here you go. So you can turn on run as PPL for LSAS, and it will make LSAS run as a protected process. This means that no other process will be able to like read remote process memory, write remote process memory against LSAS. It also means LSAS will not load any DLLs that are not signed by Microsoft, and that's good protection. However, I just want to note that in my copy of Windows 11, Run as PPL was not turned on by default. You would have to turn that on manually yourself. Later, in later versions of Windows, it is gradually getting to the point where it's being turned on by default, but it's not on by default everywhere today. So, especially in older versions of Windows, it will not be turned on by default. All right, so that's all I really wanted to go over. Thank you very much again for watching. Have Dark Mode Episode 3 out soon, hopefully. Thank you very much. Talk to you later. Bye.